welcome back to StudyOnion, and today we're going to be talking about lunar phases, and more specifically about the phases of the moon and a difference between a sidereal and a solar or synodic month. We're also going to look at a practice question and an answer to finish off. Let's get started! So, when we are looking at lunar phases, we can look at this image here, and we can see that the phases of the moon in order are new moon, a waxing crescent, a first quarter, a waxing gibbous, a full moon, a waning gibbous, a third quarter, and a waning crescent before returning to a new moon. Now be very, very careful when you see the moon titles named a quarter, because you're actually looking at a half of the moon in the night sky. The only thing, and why it's called a quarter, is because the whole of the moon is both sides of the moon. So we only ever see a half of the moon, or 59% of the moon, as we've previously covered, and therefore the part when we can only see half of the moon in the sky is actually only 25% of the moon, which is why it's called a quarter. This video, which demonstrates the lunar phases and how they would look in the night sky. Now let's take a look at the differences between a sidereal and synodic month. Now, one sidereal month is the time it takes for one complete revolution of the Earth is equal to 27.3 days. One solar month is actually 2.2 days longer at 29.5 days. And this is actually because that during the time taken for the moon to complete one orbit of the Earth-Moon system has moved an angle of 27 degrees in its orbit around the Sun. So the reason for this difference is actually that during the time taken for the moon to go through one complete orbit around the Earth-Moon system has actually moved 27 degrees, or an angle of 27 degrees, in its orbit around the Sun. So let's take a little look at this diagram. So at position M1, the moon is actually aligned with the Sun and the Earth. Now, during one complete orbit of 27.3 days, the moon has moved from position M1 to M2. And however, during this time, the Earth has also moved, and the Earth has moved significantly in its solar orbit from E1 to E2. And this means that an extra 2.2 days are needed to realign the moon, which needs to now be at M3 with the Earth and the Sun once more to create another new moon. So, let's now take a little look at a practice question. So I'm going to give you some time to look at the question and produce your answer, and then we'll come back to this. So the question is, explain the 2.2 day difference between a sidereal and synodic or solar month. I'll give you some time to think about it. Okay, so during the 27.3 day orbit of the moon around the Earth has actually moved significantly in its orbit around the Sun. And it needs this further 2.2 days for the Earth, Moon, and Sun to realign into one position. And if you want to, you can refer and draw that diagram that I just showed you. So, to summarize, following a new moon, the lunar disk shows a very thin crescent phase that waxes and becomes half full and gibbous before eventually becoming a full moon. The moon then wanes through its gibbous, half full, and decrescent phases. So, all the phases of the moon in order include new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and waning crescent. And this cycle repeats once in a month. So, the difference between a sidereal and synodic month is that although one sidereal month is the time it takes for the Earth for one complete revolution of the Moon around the Earth and is equal to 27.3 days, one solar month is actually 2.2 days longer, at 29.5 days. And this is actually because the Moon travels in its orbit around the Earth in the time it takes for the Earth to complete one orbit around the Sun. And this means that there is time of the extra 2.2 days needed to realign the Moon with the Earth and the Sun to return to a new moon at the beginning of this lunar cycle. So, I'll see you again next week with a new video about sundials and shadow sticks. But until then, bye!